there have been a lot of changes in streaming hardware, streaming software, and the ability to be able to stream, especially from a remote location. So being able to go in quickly, set things up, and be able to stream out. And encoders used to be very, very simple devices. You bring in your video input, you get your encoding output, and off you go. But these days, there's a lot of features being added to these devices to make them a lot more useful and to integrate a lot of the functionality that you would have had in a separate device in the future. Things like recording. So encoders are not just encoding, they're able to record. They're able to do some actual signal processing of the signal before it's encoded. And so I'm going to talk about some of those features as we go forward. So there are a lot of options when you're looking at an encoding platform, whether the number of source inputs, things like scaling and cropping and branding, how easily and well they integrate to CDNs to be able to push that content out to your users. So I'm going to walk through some of those features and just talk about them individually. So for the basics, I mean, the obvious first one is how many sources are you streaming? So there are many encoders on the market that are just single source in, single stream out, and that's pretty simple. But in a lot of these applications we talked about, you might want to be streaming out multiple sources, multiple rooms, and that more and more there are devices out there that can take in multiple inputs, combine those inputs into a single stream, or stream them out as independent streams. And more we're starting to see people want to select which stream they're seeing rather than the broadcaster or the person who's producing the content being the one to dictate what the user's going to see at what time. So there are the obvious first one is how many sources do you have that you need to capture and encode, and what resolutions and port types are they? So we see signals from people wanting to capture from iPads, people wanting to capture from laptops, typically cameras. So there's a wide range of resolutions, aspect ratios, and then actual input signals, whether those are composite cameras, you got SDI cameras, HDMI, laptops are coming out either VGA, DisplayPort, HDMI. So you got a whole mix of stuff there. And there are a number of platforms out there that will take in many of these different signals at the same time and be able to allow you, as we've done today, to plug in a VGA cable for one laptop or one source, plug in HDMI for something else, bring in an SDI. So that's a fairly easy thing to kind of accommodate on a modern platform. The other one is network sources. So a lot of times encoders are very focused on being able to encode and stream out directly one-to-one. But in many cases, your source that you want to encode, and you may want to combine with other sources, may be located somewhere completely different. So you've got some camera that's out in the field, or you've got some screen in a control room that you want to bring in. Being able to encode at that source and then stream it to a more centralized server, which can then process that video, so combine, do a picture-in-picture, or do some processing, add labeling or time coding, and then stream it out. We refer to that as network sources, so being able to put an encoder out in the field, stream back to a more centralized server that can then basically process that video and re-encode. So in many applications, this is a really handy thing to do. And I'll talk about synchronization of those sources a little bit later. Streaming and recording have become almost, brothers in the same house kind of thing. They used to have a recording box and a streaming box or an encoding box, and those were separate functions that were done by separate pieces of equipment, and then you often have to split in between them in order to get your signal into both. Most of the recording platforms today can stream, and many of the streaming platforms can record. So more and more we're starting to see a device that's a recording and streaming box as opposed to an individual encoder and then a separate recording device that's something that you purchase and manage separately. And post-processing of the original inputs is something that people are doing more and more often. So it used to be when you were broadcasting a live event, you would stream it out, and then when the event's done, you pack up, you go home. More and more people are making sure that they're recording all those events and then providing that client with those original files at the end so that they can then cut them up, use them for other marketing materials, other promotion. So it's not just the live event itself, it's capturing that data again for reuse after the event. So streaming and recording often go hand in hand. And of course, live production switching is another core element. So by this, I mean bringing in multiple camera feeds. So you might have multiple camera angles, or you might have slides and a presenter, and sometimes you want to show just the presenter, sometimes just the slides. You want to be able to live switch in between those things. And there's lots of live production equipment, but it's often meant for very, very big scale kind of production. And what we're seeing now is encoding boxes that can record are also building in this live production switching functionality. So you can bring in multiple sources and switch them live. So you've got a simple box that can do almost a full production without having all of these pieces and splitting all your video in between them. Some of the customizations people want to use, often your source size may not be equal to your output size. And a lot of times on these boxes, we use EDID, and you just witnessed here plugging in different sources and trying to make sure that the resolution displays correctly as you want it and is not stretched or squished or have black bars around it. EDID is for digital sources, and it advertises basically what the monitor or what the streaming device is capable of in terms of resolutions and in terms of frame rates. And often a source can misinterpret that. So 99% of the time you plug in your laptop to a screen or a device, an encoder, and it sees the resolution that it wants. It picks the 1080p or whatever it's trying to get to, and everything works great. But there are some times where that doesn't quite work the way it ought to work, and you get some cameras that you plug in that they don't quite see or interpret the EDID information in exactly the same way. So a lot of the encoder boxes have now been updated to be able to allow custom EDID. So you can go into that port and download an EDID that will force your source to get into the resolution mode that you want. So instead of having a generic EDID that advertises a whole range of options and hoping that your source camera or your source laptop or whatever it is you're capturing is going to interpret that properly and give you the aspect ratio and the resolution you want, many are able now to custom create an EDID and force that source to go exactly where you want. So you won't end up with these black bars. You won't end up with things being squished or stretched. So that's an important feature that a lot of the devices with digital ports like HDMI or DVI have available now. I talked a little bit about the aspect ratio. Cropping is another important function that a lot of people overlook. A lot of times you will not want to go out at the resolution that you're coming in at, and many times you don't need to change that aspect ratio, but there are also cases where you will. And changing that aspect ratio is difficult. You can't convince your source to do 4:3 if your EDID is saying you do 1080p and vice versa. So a lot of the encoding boxes now have a little bit of pre-processing on the front end to be able to crop out the part of the image that you want, so you don't end up with the black bars and the scaling that results from having one source in, say, 16:9 and an output that's 4:3 or vice versa. So it gives you flexibility to bring in a wide range of different signals from different devices and then be able to accommodate the output resolution that you want. Another one is flexible picture-in-picture mode. So in the early days, in a TV and that kind of thing, the picture-in-picture modes were very, very simple. So on the left-hand side, you see I've got a camera overlay on top of an image, and it's stuck up in the left corner, and I might have an opportunity to push that down in the bottom right corner, but I don't have full flexibility to scale it to exactly what I want and place it anywhere on that image I want, or place it beside the image if that's what I want. So that's another feature. When you look at picture-in-picture, many devices have it. Some of it have it in a much more flexible manner than others. And what we're seeing more and more is devices that are able to give you a background mat, so you can put your own branding back there. You can size the 2 images or 3 images or however many video sources you're bringing in. You can size them however you like and place them wherever you want. And it allows you to create a much more customized, kind of high production look to the stream that you're creating, and gives you room to be able to bring in those sources. And this is another example where you might use cropping in addition to this flexible layout where everything's coming in 16:9, but the talking head you have in the corner, you may not need that wide ratio. So you may not want a wide HD version of the talking head. You can crop that down and create a square version or a 4:3 version and tuck it up in the corner, giving you more real estate for the main pictures or videos that you want to show. Watermarks, timestamps, and backgrounds are another bit of post-processing, and the big production switchers take that to the extreme where you can put statistics on the screen and use your lower thirds to do all kinds of animations and those kind of things. Without going to a full sort of production switcher, there are lots of little features like timestamps copyright notice text, logos, and overlays that are more static in nature, that are built right into the encoder. So you can pre-program these things, upload JPEG images, whether they're logos or text that you want overlaid, or even timestamp that's real time that becomes part of the video. And in certain applications, that's critical if you're capturing, say, evidence or some kind of detail that needs a time code that's part of the actual data itself and not metadata that goes along with the file. These are features that are built into many of the encoders today. Auto resampling is another one that often gets overlooked. People just they focus on the video and they forget a little bit about the audio. But one of the features that's really handy to have is this ability to resample the audio. So if you're coming in with digital audio and you're coming in at 44 kilohertz at 16-bit at a certain encoding, to be able to re-encode that so that when you're producing video from multiple sources, your output file isn't changing format as you switch video streams. And when you're creating a library of streams for people to view later on, you can have consistency in that library. So regardless of whether your source was coming in at 16-bit or at 12-bit, or whether it was done at 44 kilohertz or 48 kilohertz, if your encoder can automatically resample, then you can dictate what the output format is and accommodate whatever input format you're giving. So when you connect up your camera, you don't need to worry about matching the settings from your source to your encoder to make sure everything flows smoothly. You can just instruct your encoder to take that data and resample it out at 48 kilohertz or 44 or whatever it is you need it to be. So that's a handy little feature that a lot of people overlook. When we get to more advanced customization, matching the stream to the available bandwidth is a critical one. So being able to flexibly create multiple streams. One you may be streaming out at a low bit rate, say 2 megabits or 3 megabits per second, to make sure you've got a link that can handle that. Meanwhile, you may be recording something at a much higher bit rate so that you can go back and post-process it later. So having the flexibility, not just to select a couple of bit rates, but to really have flexibility to tune it to the network that you're seeing at the event that you have. So once you know what that network is, you're able to tune the bit rate, and if it's 3.5 megs, you can set it to that. If you're only getting 2.5 megs reliably, you can scale it back. So it's important to have that flexibility so that when you're walking in from venue to venue and your conditions are changing, you're able to adapt your gear and say, all right, I don't have the 5 megabits I had at the venue I was at yesterday. Today I'm going to have to deal with 3 megabits, and you can instruct your encoder to deal with that, perform any scaling if you need to down to 720p or something smaller in the process. So being able to match that bandwidth is critical to make sure that your signal gets out and is usable by the people you're trying to reach. Multi-encoding is another kind of key concept in most of the encoders today. So it started out where most encoders were single input, single encoding, you set one bit rate. And more what we're seeing is multiple inputs, multiple encodings, so that you can be streaming out to different audiences with different form factors. So someone viewing it on an iPhone may get one stream with a certain encoding. Somebody on a desktop's getting something different, maybe at a different resolution or a bit rate. But being able to do all those things in parallel is important. You can always, of course, create one and then use cloud services or streaming services to transcode on the fly. But it's, in many situations, a lot more efficient and easy to do it in the encoder itself. So if it's able to do multi-encoding, then you're able to create those streams right from the start and send them out. Of course, you need the bit rate to be able to do that, but it's a very handy thing. And another thing we see people often doing is recording input at a high resolution and a high bit rate, streaming it at a lower bit rate. So the exact same inputs and the exact same layouts, so the stream is identical, but they're using one for streaming and the other for recording. So you can always go back to the recording that's at a higher bit rate if you need to post-process those files. Configuration, save, and recall. This is just another handy feature for people who are going into events. You may show up, you may be doing a keynote in one room and a bunch of breakout sessions in another. It's nice to be able to pre-program that encoder to have all those settings already set up with your branding, with the layouts that you want, the bit rates that you want, everything set up, and have multiple presets stored in the device so that when you show up at the venue, you're not having to enter all that data, set up the system. You've already done that back at the shop, and now you're just selecting presets and being able to call up, pull up my keynote address, that will bring in the right number of inputs, scaled at the right way you want, cropped the way that you want, and encoded at the bit rate that you want. Another one is we do see a lot of people who are doing live event production having to serve many, many rooms at the same time. So if you have a large conference with a large number of breakout rooms, you will have many of these boxes that you have to set up in advance, and being able to propagate all of the configuration data from one box automatically to, say, 20 others is a really handy feature that saves you a lot of time and reduces a lot of errors that get into the chain as people try to provision 20 boxes in an identical manner. So being able to have an encoder where you provision one, you set it all up exactly the way you want, and then you basically point this to the other 19 and say, please replicate this exact configuration with all my branding, all my bit rates, everything to the other 20 boxes that I'm taking to this show. So it's a real handy feature that not many encoders have, but some are starting to have now. That if you're dealing with live production scenarios where you have many outputs from your venue or many rooms that you're encoding from, being able to propagate those and make sure that they're all identical is really key. Integration, of course, into a CDN. This is another one that where it saves a lot of time. It removes a lot of the mistakes and gets you up and running on site much more quickly. So a lot of products are now very tightly integrated into the CDN so that you can just select, I want to be streaming over YouTube, or I want to be streaming over Wowza Streaming Cloud, or Akamai, or whoever your CDN of the day is that you want to be streaming. You can have all that preset up, and a lot of them now, rather than manually typing in SDP points and port numbers and all this kind of information, one example is Streaming Wowza Cloud will connect. If you set up a service with them, they'll create a connection code. And some of those, so it's just a little 6-digit code, and we have some encoders where you just take that code and you enter it in and hit enter, and it will set everything up for you. So it will go to the Wowza server, it will identify the stream, it will figure out what bit rate you want streamed at, and it will basically configure the encoder and start streaming live. So that way you're not replicating all of the mount point and port information manually and typing it into all of your encoders. You just get a simple connection code, you fire it into your encoder, press enter, and you're good to go. So more and more we're starting to see products like Wirecast and other encoding software as well as hardware devices being much more tightly coupled to the individual CDN services to simplify the setup at the site and make sure that there's no sort of typos that cause errors. Streaming anywhere from, or to anywhere from anywhere. So this is one that Terabek just talked about. Being able to have something like a 3G or a 4G stick or bonding across those sticks as a backup, right? So normally you're going to want to have that Ethernet drop, as he spoke about. You plug in and everything's good to go. But there are those cases where things don't go exactly as you expect. You're not getting the bit rate that you want, or the guy forgot to put the Ethernet drop, or he forgot to open the port. Having something where you can fall back to a wireless solution, a cellular solution, is a really handy thing that can kind of save your butt. This device is Epiphan Pearl, so I'm going to start to talk a little bit about our individual devices. So this is one of those all-in-one encoders and recorders that I've been talking about. It has multiple inputs on the back of it. It is able to, so this isn't working exactly the way it should. I should see the back of that, but there are multiple ports on the back, and then you're able to create multiple output streams from this device. So you can create 5 output streams at 30 frames per second at HD, and you can have 4 HD inputs coming in. And you're able to mix and match those, create different layouts, put your own custom branding behind it to create something that really looks like a custom stream, something that is suiting your audience or multiple audiences. So one of the examples is we have people broadcasting football in Texas, and depending on where the viewer is, they'll see a different stream because they're inserting advertising into the space that they have around the content. And they'll send one stream out with certain advertising. They have a different stream where they're inserting different ads because they're going to different locations and they're being paid to advertise differently. So it's handy to be able to multi-encode and be able to stream out multiple inputs. We also have a product called Standalone VGA Grid, which is a big server-size product that has 12 HD ports on the back of it. So if you're in a very, very large production, this thing sits in a rack, but you can wheel that rack up and then connect up a whole bunch of different cameras, laptops, iPads, whatever it is you're capturing from, and be able to do live streaming and recording of all of those directly from one system. So they do scale to get fairly large. We also have a product called Network VGA Grid, where you can locate your encoders out in the field, stream the data back to a central server, and it will synchronize the data from all of those things. So the delay between the encoder that's sitting in the field and the server that's actually going to do that picture-in-picture or combine those sources into your stream is able to compensate for that network delay and make sure that it compensates for sources that have large delay or small delay, aligns them back up and synchronizes them. And so this can be really handy if you're bringing in remote sources from the field or from a different building, and you want to make sure that that network delay isn't obvious in the stream that goes out. You want to synchronize those things back up before you're sending that data out. And this, I'm not going to go through this whole chart, but it just gives you a view of some of the products that we have and some of the features that I've been talking about and how they kind of line up. So some of these features we have, some of them we don't have, some are coming soon. But a lot of what I've talked about up here is built into our products. So the ability to have multiple inputs, to multi-encode, to crop, to auto sample or resample your audio to match what your output configuration is. A lot of these things are built right into the encoders. So more and more we're getting away from a simple box that's an encoder to something that is more of a streaming and recording platform that's got a fair amount of smarts in terms of pre-processing that signal before you're going out and encoding it. And that's the whole talk that I had. So if anyone has any questions around either the products or the features or anything like that, I'd be happy to answer. No questions? None?